Hi, this is Lori and welcome to my series on the Pico W. This is part 9 in the Exploring LED Displays series. In this episode, we'll daisy chain 2 shift registers to control 2 bar graphs. In part 4 of this series, we introduced the 74HC595 shift register, and part 4 was a pretty detailed a description of the shift register, and we went through how it works very carefully. So we'll just do a little reminder in this episode about the shift register. But the one thing we haven't done as we've gone through this series, and we've used the shift register now with the bar graph, with a 7-segment display, and with a 4-digit 7-segment display, we have never used 2 shift registers together. And if you read about that, one of the advantages, or one of the nice things you can do with them, is you can daisy chain them together. And as we see here, we get 8 outputs from one shift register, and we could take and daisy chain 2, 3, 4 of these shift registers, and we can increase the number of outputs for our microcontroller each time we add another shift register to the circuit. I thought it would be good to go over how to do daisy chaining. I hadn't tried it yet myself. And in the last episode, I mentioned that we were going to work with the 8x8 LED matrix and use 2 shift registers. But as I started to put all that together, I realized that the bar graph might be a better place to start. Well, this is a slide that I took from part 4 as well, where we discussed in detail the pins and their function and the pinout for the 74HC595 shift register. I'll just remind you that pin 9 was QH prime, and we haven't used this pin at all. It's been totally unconnected. That's the pin we'll use to chain together our shift registers. And it's pretty simple. If this is our first shift register, and this is our second shift register, we'll take the QH prime from the first one and we'll connect it into the serial input pin of the second one. So as we shift the bits out of this shift register, they'll come out QH prime and then start coming in the serial input of the second shift register. And now you'll also notice that I show the clock pins and the clear pins connected together, and that's so that we can operate both of them at the same time. So we can tick the clock and we can clear and flip the latch at the same time. So we'll interconnect those, and then these will all get connected back to our Pico, as well as the first serial input pin will also be connected to the Pico, so that we can send in the data that we wish to shift through the first register, out the QH pin, and then shift it into the second shift register. Here's the circuit we'll use in this episode. It's pretty complicated with the wiring, as all these LED displays have been. So you do have to be kind of persistent in getting it all connected up and making sure you don't have any connections in the wrong place. Not only have I had to rewire that circuit in real life, I've had to redraw this circuit a few times in fritzing. It's easy to put wires in the wrong place and miss it. But anyways, I've said this before, so just one of the challenges in working with these LED displays when they don't have the driver chips. So we'll have our 2 shift registers here, and then each of the bar graphs. Now I've decided only to use the first 8 LEDs from each of the bar graphs. So these last 2, 9 and 10, will not be connected up. As you can see, they're not connected to anything. And same over here. And that's, I just decided to do it that way. Maybe another project that could be done is to include 3 shift registers and control all of these LEDs. You'd only need sort of half of another shift register to control the last 4 LEDs. That would be an interesting project to do, I think, as a follow-on to this. And anyways, we're going to use those first 8. And you can see I have current limiting resistors here As I've done in the other episodes, I will be using a network resistor. It's a 470 ohm network resistor. It might be a little more resistance than we need, but I think it's a good strategy here. We're potentially lighting a lot of LEDs at once, so having a little more limitation to the current is probably a good thing. And you can see that the first LED is connected to the QA pin, and the second is to the QB, C, and all the way down. And both of the setups are done exactly the same way. First LED to QA. So you have to decide how you want to do it. You could hook it up the opposite direction or any direction you want, but you just have to keep that in mind to know, as you shift the bits through, which ones are you turning on and which ones are off. And now you can see, I guess the most important thing is here's our QH pin from the first shift register. So this will be the first one that's connected up to the Pico. We'll take that QH prime pin and connect it back to the serial input pin of the second shift register. And then you can see I've also interconnected the two clock pins and the clear pin to the first shift register, which of course is then connected back to the Pico. So that's the setup, and while it takes a lot to wire it, once you kind of get it set up, it does work pretty well. So let's get some programming done. We'll do a pretty simple beginner level program just to kind of visualize how these daisy-chained shift registers work. Kind of similar to what we did in part 4. So we'll import the libraries we need, and we'll do the setup of the shift register. So this should be very familiar if you've been following the series. We've written all this code before to set up the shift register, create some functions to clear it, to tick the clock, and to flip the latch pin. And we do a clear out before we start. We'll have a little variable in here to put in a delay, so as we go along, it'll make the LED that we're lighting move every second. So what we're going to do is shift in a 1 into the first QA on bar graph 1, and then we're going to shift it from, I should be pointing over here, bar graph 1 from QA to QH at bar graph 1, and then we're going to keep pushing it on down into the bar graph 2, or the second shift register, to go through the QA and QH in that shift register. So basically we're going to light, you can show that on the circuit, we're going to light these LEDs one by one. So we're going to push in our 1, then we're going to shift it on down, and then continue to shift it on down. So we'll see a lighted LED move down across our bar graphs. And so I've written a lot of comments in this version. That's kind of why I call it a beginner version. And it doesn't use a loop, which I'll show a more advanced version with a loop, showing how much simpler this is, and of course take out all these comments. But if you're trying to work out shift registers for the first time, I think it's helpful to have all these comments. So we'll send in a 1 or a high signal on the serial input pin. So that's going to go into the first shift register. We'll tick the clock to put that into the register, into the QA spot. So that's where we are. And then we're going to flip the latch. So this should be the status of all the pins on the 2 bar graphs. And so this is the one we should see lit, and everything else should be off. And I'll just show a couple of these. It keeps going down the line. So now to move that 1 down, we'll send in a low. And by doing that and ticking the clock there, we'll put the 0 now in the QA spot, and the 1 will shift down to the QB, and everything kind of gets pushed along. And flip the latch so that we see the second LED on the first bar graph lit, but everything else should be off. And we'll just keep doing that. We'll keep sending in lows, and so that's what this does. And I'll scroll along. You can see it's a very verbose code just for understanding purposes only. And so we'll get to the very end here where we've pushed that 1 or that high signal all the way to the second QH on the second shift register. And so that should light that last light, and then we'll sleep the delay and clear everything out. Okay, so we'll go ahead and give this a go. Yeah, so we can see it moving along here. And get my little pointer up. Yeah, you can see it moving into the second shift register and second bar graph. And then it should turn off. Yeah, so that's how we shift the bits down through the 2 shift registers. All right, so when you're repeating yourself over and over again like we were in that last beginner code, it really would be better to use some kind of a loop to do the repetitive tasks. So I called this a streamlined or advanced version. Not terribly advanced to be using a loop, but I just thought it'd be nice to show how much more simple it would be if we did it in a loop format. So all the same setup. I'm going to speed up the movement of the LED substantially here. Instead of taking a whole second, we'll do 0.05 seconds when we move the LED along. And we'll use the try and accept approach so that we can press Control-C and just turn everything off when we're done watching this. So this will just keep looping and moving the LED back and around and around and around. So first we'll send in our 1, tick the clock, flip the latch, sleep the delay, and then we'll move that 1 down by repetitively sending in low signals until we get all the way down to the last place, and then we'll come back around and clear everything out and start over again. So let's take a look at how that would look. Much simpler code, and it's much more fun because it's moving faster. It's not filming real great, but I think you can see the LED moving along. So you can have a lot of fun moving that around. And so once you start looking at that, you think, well, it would be fun to do some other cool patterns, moving the LEDs and so forth around using our shift registers. So let's do a couple fun programs for that. All right, for the first one, we're going to light every other LED, and we'll kind of flip back and forth between 2 settings. So you can see this will be the way we want the bar graphs to be first time, and then we'll invert it for the second time, and we'll flip back and forth between the 2. And so it should kind of look like it's shifting back and forth, back and forth, back and forth. So pretty simple. Now the other thing we're going to add here in this fun program is we're going to go ahead and write the 16 bits at one time, because we have everything chained together, so we can just send the whole sort of binary number into our shift register so that we fill it up with this pattern, and then flip the latch, and then we'll fill it up with this pattern and flip the latch, so we don't have to kind of do what we were doing before, where we were just kind of sending in one number at a time. We'll send everything in pretty quickly, and we use a function for that. All right, so it's very similar to the function that we had in part 4, just increasing it so that now we have 16 bits to work with instead of 8. So now you can see we're looping all the way to 16, up to but not including, and we'll work through the bits, determining whether to send in a low or a high signal. We'll tick the clock, flip the latch. So I've called that the write num function. We used it also for 7-segment displays and things like that. So we'll just do what we've done before, clear everything out, set our timing to 1/10 of a second, and you can see it's pretty simple now. We'll write in the 1 pattern and we'll sleep the delay, and write in the sort of inverted pattern, sleep the delay, keep looping around until we do a Control-C. So let's take a look at this one. Yeah, that's fun. It'd be even neater if they were together on the board and all one continuous piece. This was easier for wiring and understanding, but if I was really using it to make some fun displays, I'd have the bars together, and I'd probably throw in that 3rd shift register so that we could use all the LEDs. But still, this should get you started, and it's kind of fun to play with. Let's try one more. Okay, for our final program for this episode, we'll do an LED chaser type example. So all the same setup, our right num function, and then we have two loops here to move the LED up the display and then back down the display. And since we're not doing it like we did in the very first program where we kind of pushed it one by one by one, we want to send in whole numbers at a time, whole binary patterns at a time. We can use powers of 2 to do that. So let me switch over to a slide just to show you what that looks like. So here's our code that we used, and if you print this out, you'll see what number we're sending in. So this is putting the first LED on, and then you can see that we lose one on the end, so there's actually one sort of in front of this. So we're moving on down the line, hitting the end, and then we're pushing it back up all the way. And you can see I purposefully looped over slightly different ranges so that we don't duplicate any and hold it for too long. So that's what the power of 2 will allow us to do with binary numbers, and that allows us to make it a really simple loop to do our LED chaser. Well, we've seen how powers of 2 look as binary numbers. So that's going to allow us to move the LED up and down the display as we wish, and we'll add in our sleep so that we have a slight delay, have a chance to see the LED moving, and we can change the timing and have fun making it going fast or fast or slow. And we have it now in our try and accept approach so that we can stop it whenever we're done. All right, let's see this chaser go. Yeah, that's fun. And I'm sure you can think of a lot of interesting patterns you might do with this kind of setup and a couple of bar graphs. So it was fun seeing how the daisy chain shift registers work, and getting to play around with the bar graphs again. Now in our next episode, we'll use 2 shift registers with an 8x8 LED matrix, and I'll be using them in a different way. I won't chain them as we have here. I'll use them independently or almost independently. So that should be a good episode. I hope you'll join me for that. And as always, I want to thank you for watching.